Hello, my name is Pranav, and I'm from the Robot Simulator team, along with Melody Lu and Sonnet. So, the goal of our project was to create a robot simulator that can be controlled from a HUD UI so that there can be more on screen movement so that can be controlled from a phone browser or any other type of browser that is not a computer.
For our project, we use Babylon.js, which is a 3D graphics engine based on WebGL, and that's a JavaScript web rendering library. We use it to handle the graphics so that we can avoid having to create our own graphics rendering program, which isn't our original objective. The Canon.js plugin was used alongside Babylon.js in order to implement physics logic in our project. We also used Netlify in order to deploy our project onto the web.
So a huge part of our project was the rendering that we did because that was the main part of how we created our environment and all the pieces that you saw. So for the rendering, we used Babylon.js and we created balls, goalposts, and the environment. The environment being like the walls and the floor. We also used that to create the robot and then all the parts that moved. So we rendered the balls so that you could hit them with a robot and move them around. And then we also rendered the goalposts so that the balls and the robot could later interact with them and that they would all show up and look nice in the when you opened our project. So what we did for that is we used a lot of Babylon, and if you look at our GitHub code, here's the main.js, or where we used our Babylon to render the individual pieces. You can see that here we're using it to render the room with like all the parameters and the create ground, create plane functions. And then we also use that to create the robot and the wheels on the robot. And we use a lot of functions like create box, create cylinder, and later for the goalposts as well. We rendered them all using Babylon.
As our robot simulator is rendered as a 3D environment, we naturally had to take lighting into account. The lighting and shadow calculations were handled by the Babylon engine, as the way that light bounces around a 3D environment is really complex. When it comes to small details on our meshes, such as the tiny ridges and scratches on a soccer ball, it is even harder to predict. Not to mention, it's also hard for the programmer to write code for every small shape on top of the basic sphere. This is why we use something called a normal map, which is basically an image that gives information about the 3D shape of an object. It is put on the surface of a mesh to make it look like it has more dimensions than it really does. There are also different types of lighting, such as hemispheric, which is basically ambient lighting, and point light, in which light is emitted in every direction from a single point. So this is how our soccer ball is created, as an example I was talking about. There are three basic components: the texture, which is seen over here, the basic spherical shape of our ball, which is right here, and the normal map, which is, as you can see, like an image of special colors that have information coded with them. And you put all of them together and set in the environment with point light, then it looks like a realistic soccer ball. But if you look closely at the complete version of the ball, you can see that these are actually real. They're a lighting trick made possible by the normal map.
The part which I worked on in our project is a GUI, which stands for Graphical User Interface, and this was used as on-screen buttons in order to move the robot so that there can be on-screen buttons on there instead of having keys such as WASD, so that it can be more accessible to other browsers such as a phone browser. So in order to move the robot using these on-screen buttons, we use methods like .translate and .rotate, which is used in our code. So here you see our GUI right here, and we used the advanced texture in order to create a full screen UI so that they could be the buttons are shown throughout the whole screen instead of just parts of the screen. So we added different buttons like the right button, left button, the up button, and the down button. So within the right button, so we had these different PNGs and to display our button, and we added different properties to the button, like left, top, width, height, and thickness, in order to display our button much more cleaner. So at the end of our GI, we added this thing called add control, which was used as a control, which means so a control is used here as, so it helps organize a UI using a container, and you have to use different properties like that add control in order for the UI to be much more cleaner. So that is why we used the add control method right here. So as you see, we use the similar methods right here for each button in order for there to be much more cleanliness in the UI. So after that, so in order for there to be movement within GUI, we had different properties called. So we had the on pointer down observable, which is shown in the GUI here, which is so here you see the on pointer down observable, which is right here, which means that when the buttons are clicked, when they're held down upon, then the robots start to move. So that is why we use the on pointer down observable for each of our buttons. So next, I also worked on the scoreboard, which was to add two different scoreboards to the split screen in order for it to be a scoreboard on the left robot and the right robot. So this helps render the score for both teams, and it's shown on the scoreboard so that both teams know what the score is and they have the objective to win. So the scoreboard shows the red team and the blue team. So after 5 goals are scored, the game's function is that it displays a "you win" text on the scoreboard to show that one team's won while the other team's lost. So in the code, you see the scoreboard, which is shown right here. So the scoreboard right here is shown. So we've had a scoreboard, and we used a mesh builder and a create plane in order for the scoreboard to be displayed properly. So we added different positions using the vector 3 so that it is displayed on the high point of both screens. So we used different properties like width and height in order to adjust the way that the scoreboard is shown, and we added text on the scoreboard to show the red team and the blue team score, and our score variables are shown right here, and we used different properties like score 2, and we used so we had score 2 if it's greater than 5, then the red wins. The win text shows the red wins, and that's also shown with score. So these properties are used to help display the scoreboard and display the winning team on the scoreboard.
The physics of our robots then were done with the Canon.js plugin. Physics includes stuff like gravity, collision, applied forces, and velocities, and those things correlate with movement. These things are based on the Canon.js physics imposters, but they only support basic shapes like spheres, boxes, and cylinders. The more general physics imposters that all shapes was kind of buggy, so that couldn't be used, and that forced me to apply imposters on every individual component of a mesh, which caused a lot of performance problems. What's more, everything falls apart after physics are applied onto meshes with parents, which means that that mesh has the transformations and translations based on a single mesh. So yeah, that part caused a lot of problems, and some of it we still didn't figure out. Some further work that we can do on our project is to definitely add more features to our robot, like an arm, a mechanism to intake and shoot balls, among other stuff. And we'll add more rooms in our simulator in order to utilize those features. We can also add more like indicators for when events occur in the game, so that players can easily tell what's going on, like adding a glowing particle effect or sound for when a goal is scored. We should definitely optimize it as well, since the frame rates right now are a bit of an issue. And we can also add remote control from a different device, which is the original plan. Through this project, we learned to effectively use GitHub for collaboration, basics of 3D rendering and game dev.
When looking at this project, this helped me learn so much about, helped me gain a lot more experience with JavaScript within Babylon.js, and it showed me that communication is very key to have effective group work. And without having each person on point and knowing exactly what to do and what to contribute to the team, that's the only way in order for our team to function well, in order for the task to be done well and properly.
Here's the contact info for every group member. Thank you for listening.